Hey, y'all look great. Y'all look great. Alex, I mean, um, what are you your grandmother? Sorry, that was maybe a bad joke. Are you somebody's grandmother? Or what's I haven't watched the movies, but um, Medea, what or what is it? Um, what's his name? He dresses up as all the characters. Yeah. And then we have a ghost over there. Hello, ghost. William likes ghosts. Yeah, kid songs that have ghosts, um, like Five Little Ghosts and all that stuff. He loves that stuff. So he would have fun with the ghost. Um, cool. Well, what do we have going on today? We are going to address questions over assignment 16, rational functions, and then we will take our quiz. So I have a quick set of announcements that I want to make. Number one, um, I have not made the videos yet for assignment 17 and 18. Um, I'm going to get the videos made for assignment 17 this afternoon. That is my goal that's going to happen before I leave home this afternoon. So you will have access to assignment 17 videos by the end of the day. Um, assignment 18, I would love to get to them today. I just don't know if that's going to happen. Um, and so if I don't get to them this afternoon, hopefully I will get to them later this evening, after all my kids are in bed. And so it'll be a late night making videos. I got to get to it then, otherwise I got a busy weekend ahead of me, so those assignment 18 may not happen until Monday next week. But you will have access to assignment 17 videos by the end of the day. And assignment 18 videos will be up at the latest. The latest that they will go up will be Monday night. That way you can watch them on Tuesday. That will be the latest. So just be patient with me as I get those videos made. So with that being said, that's what I have in terms of the videos. Let's talk any potential homework questions that you have over assignment 16. Do y'all
Number
have any?
four.
Number 4. Okay, let's get going. Let's see, need to get to the homework. Give me a second. Okay, here we go. Number 4. So we are looking at assignment 16, problem number 4. We have the function f of x is equal to 2x squared plus x minus 3 all over an x squared plus 5x. Okay, so the first thing that we want to do here is I always like to think about factoring. Uh, Basically, what I'm going to do is I'm going to start graphing this function. Um, I'm going to kind of ignore the steps A, B, C, D, E, and F and all that stuff. And I'm just going to start graphing. So I'm looking at the numerator. AC method, what are the factors of 2 times negative 3 is a negative 6. What are the factors of negative 6 that add up to 1? That will factor because there are factors of negative 6 that add up to 1. So 2x and 2x, those factors of negative 6 that add up to 1 are going to be a positive 3 and a negative 2. So you need 2x and x to make a 2x squared. We need a negative 2x, so we'll put a minus 1 right there and a plus 3 right there, and that'll do it. 2x times x is by 2x squared. 2x times negative 1, and then 3 times x, that's going to be my 3x minus 2x, that will give me my plus 1x. Positive 3 times negative 1 is a negative 3. Okay, and in my denominator I have a GCF of x, so that leaves me with an x plus 5. Alright, there is the factored form of our function. By the way, I'm just going to call this P of x over Q of x. That will fit in with the notation that we use in the homework. Okay, and in no particular order, we're going to start finding the things that we need in order to graph this function. So, this is not A, that's in the homework. I'm just calling this part A. I want to find the vertical asymptotes. Alright, so to find vertical asymptotes, we need to basically solve Q of x equal to 0. Set your denominator equal to 0 and solve. So we have x times x plus 5 is equal to 0. We can use that zero product principle, set each factor equal to 0. And we get that x is equal to 0 and x is equal to, I want to use a different, like x is equal to negative 5. So I didn't want to circle those in, I want to highlight these in. These are my vertical asymptotes. Alright, so far so good? Thumbs up, thumbs down, thumbs up. So far so good, great. Now we want to go and find that horizontal asymptote. And to find the horizontal asymptote, we need to compare the degrees of P of x, which we'll call the degree of P of x n, and we need Q of x, which we will call the degree of Q of x m. And this should line up with what we talked about in the notes. So, going back to my original function, n is equal to 2, m is also equal to 2. We're looking at the degree of my numerator and the degree of my denominator. So, since we have that 2 is equal to 2, we can say that n is equal to m. And then, I don't remember what page it is in your notes, but when we talk about horizontal asymptotes, if n is equal to m, that means that our horizontal asymptote is y is equal to a over b, where a is the leading coefficient of your numerator and b is the leading coefficient of your denominator. So the leading coefficient of my numerator is 2, the leading coefficient of my denominator is 1. So that means that y equal to 2 is our horizontal asymptote. Alright, so far so good. Everything making sense? Alright, moving on. After we find our asymptotes, we want to find some intercepts. To find those x-intercepts, we're going to set P of x equal to 0. We're going to set our numerator equal to 0. So, I like it that it's already in the factored form. 2x plus 3 times an x minus 1 set equal to 0. So we already know what we're going to do. We're going to set each factor equal to 0. So if I set 2x plus 3 equal to 0, I'm going to subtract 3, divide by 2. That gives me x is equal to a negative 3 over 2. And over here we have that x is going to be equal to a positive 1. By the way, 3 over 2 is the same thing as 1.5. Just a little side note. Alright, so there are my x-intercepts. And next we want to find that y-intercept, d, y-intercept. And to find your y-intercept, this is very familiar. We're going to evaluate the function at 0, f at 0. Now, if you just take a look at our function, if you plug in 0, right away, you can, if you look at this denominator, you have 0 squared, which is 0, plus 5 times 0, which is 0. You have 0 over 0. At this point, I don't even care what the top is. The top is going to be negative 3, but you end up with negative 3 over 0, which is undefined. Which then means that we have no y-intercept. Which makes sense. It should make sense because if you go back up here to our vertical asymptotes, we have a vertical asymptote at 0. Remember, those vertical asymptotes are where the graph is like a vertical barrier that the graph cannot cross. So how can you have a y-intercept on a vertical asymptote? You can't. Now, with all this information, I can start getting a sketch of the graph. So let's start doing this. X-axis, y-axis. Here we go. I like to start off by doing my vertical asymptotes. So we have 1 at 0. So I'm just going to put a dotted line. That's x equal to 0. That is a vertical asymptote. And we also have 1 at negative 5. 1, 2, 3. You know what? I'm not going to even bother counting these out. I'm just going to put negative 5 right here. So x equals negative 5. There is our vertical asymptote, another VA. And then I also have a horizontal asymptote at 2. 1, 2. Y equal to 2. That is our horizontal asymptote. Alright, and then let's start plotting some points. What do we have? We have x-intercepts at negative 3 halves and 1. So here's 1. And 3 halves is a negative 1.5. I'm just gonna throw that right about here. I'm just going to throw it right about there. And at this point, we want to start sketching this graph. Now, we can do a lot of things. We can start to do a lot of things without even plugging in points into our calculator. So I want you to think about this when it comes to graphing. Number one, the graph can never ever cross these vertical asymptotes. They're barriers. Can never cross them. Number two, as your x's get bigger, or as your x's get smaller out here towards negative infinity and positive infinity, the graph has to converge to this horizontal asymptote. And thirdly, these are the only places that the graph crosses the x-axis. So it can't cross the vertical asymptotes. The only place that this graph is going to cross or touch the x-axis is here and here. And as x gets really, really big, or as x gets really, really small, we converge to the horizontal asymptote. So if I look to the left of this vertical asymptote, the only thing that this graph can possibly do is this. Now, why can't it, I'll just draw this out. Let's just do it in a different color. The question I'm asking you is, why can't my graph do this? Can't it just go down and then converge at the horizontal asymptote? Why can't the graph do this? Well, there's a reason why the graph can't do this, because if the graph did this, it would cross the x-axis, meaning you would have another x-intercept. And what did I say? The only x-intercepts that we have are at -3/2 and +1. Those are the only two places that the graph crosses the x-axis. So the graph can't do what I wrote in green, because if it did, it would cross the x-axis, meaning you'd have an additional x-intercept, but we know that we don't have an additional x-intercept. So the graph has to do what I did in blue, and you can prove it. Here's the proof. Here's the proof. Do something like f at -10. Do something like f at -10. And I'm going to show you that f at -10 is positive. And I'm not going to even plug anything in. Well, I'm not going to do a whole lot of calculator work. If you plug in -10, -10 squared is going to be a positive 100. Then you multiply that by 2, you get a positive 200. Now look at what you then do. You then subtract 10 and subtract 3. Well, that's still going to be positive. The numerator is going to be positive. And then if you plug in -10 down here, -10 squared is going to be positive 100. Alright, yeah, you're going to subtract 50, but 100 minus 50 is still positive. You end up with a positive over a positive, which is positive. The graph exists above the x-axis for everything that's less than this -5, and in fact it'll also be greater than this y equal to 2. So that's what the graph has to do to the left of this vertical asymptote. Now let's talk about what the graph is going to do to the right of this vertical asymptote. I see two possible options. Well, actually, I only see one possible option. Remember, the graph has to converge to this horizontal asymptote. So I'm just going to put a line like that. The graph has to converge to this horizontal asymptote. Now, think about reading the graph from right to left. So here I am on the graph. I'm going to the left. Now, what does the graph have to do? At some point, it has to interact with this x-intercept. Now, since this x-intercept at 1, the exponent was 1. Since 1 is odd, that means the graph is going to cross the x-axis. Remember, if this was an even exponent, that means it would bounce on the x-axis, but since it's a 1, which is odd, it's going to cross the x-axis. The only thing that this graph can do is this. That's the only option that this graph does. Now, you can prove it to yourself. If I do f at 10, I'm still going to get a positive value over a positive value, which is positive. So for values like 10 and on, the graph is going to be above the x-axis. Now you'll notice that between 1 and 0, the graph is below the x-axis. So if you do f at 0.5, and this is where I'm going to use a calculator to do this. So in my calculator, I'll do open parentheses 2 times a 0.5 squared. Oops, that should be a 0.5. 0.5 squared, and then plus 0.5 minus 3. All right, so that's my numerator, close parentheses, divide. Now my denominator, so we have a 0.5 squared plus 5 times 0.5. Close my denominator, hit enter, and what do we have? We have a negative 0.72 or 7272 blah 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 blah. I don't even care about that value. I just showed you that it is negative, which matches up with what our graph is doing. Alright, so far so good. Everybody hanging with me? Now the question is, what's the graph doing in the middle? Now there's two options that I see. One option is that the graph is above the x-axis. It's going to come down. It can cross the horizontal asymptote here in the middle. So again, I stated this in the notes, I believe. I hope I did. Do not think of the horizontal asymptote as a boundary that the graph cannot cross. It's what the graph converges to as x goes out to infinity or as x goes out to negative infinity. But here in the middle, close to 0, we can cross that horizontal asymptote as many times as the graph will allow us to. So I see two options. Either the graph comes down through my x-intercept and then continues going down, or the graph is coming up, crossing the x-axis and continue going up. It's not going to bounce because, again, the multiplicity of that 0 is, or the multiplicity of that x-intercept is 1. Again, that means it's going to cross the x-axis. So what is this graph going to do? Well, all you got to do is show that either it is positive or negative to the left of this point. So maybe I'll just do f at negative 4. F at negative 4. And sometimes I like to use the factored form to do this. I think it's easier that way. So if I'm looking at the factored form of this function, check it out. Negative 4 times 2 is negative 8 plus 3. In fact, I'll just come up here. Let's plug in negative 4. F at negative 4. I'm looking at this. And I'm not going to even plug in the numbers. Or I'm not going to even look at the exact values. Negative 4 times 2 is a negative 8 plus 3. That's going to be negative. So you have a negative. Negative 4 minus 1 is a negative 5, so that's negative. Then you have a negative 4 times a negative 4 plus 5. Oops, I didn't mean to write negative 4. I just meant to write negative. Negative 4. Then a negative 4 plus 5, that's going to be positive. So what do you have? You have a negative times a negative, which is positive. A negative times a positive, which is negative. A positive divided by a negative is negative. So that means when I plug in f at negative 4, I get a negative answer. All right, negative. So what does that mean? F at negative 4 is below the x-axis. So what does the graph have to do? It has to come up and then go up like that. And again, you can prove this. All right, well, what about f at negative 1? Well, negative 2 times negative 1 is a negative 2, plus 3, that's going to be positive. The negative 1 minus 1 is negative. Then you have a negative. Then negative 1 plus 5 is positive. So you have a negative times a positive, which is negative, over a negative times a positive, which is negative, and a negative divided by a negative is positive. So it exists above the x-axis. And that's what our graph has to do. Now, this trick, I don't even call it a trick. This technique of plugging in values and not really caring about the numerical value, but just caring about whether the output is positive or negative, is a really nice way to get the sketch of these graphs. Because remember, all we're doing is sketching it. When it comes to me evaluating your graph, here's what I care about. I care about things like, where are your asymptotes? Okay? Do you have the correct asymptotes? Do you have the correct x-intercepts and possibly y-intercepts? And is your graph behaving like this? I don't care that you're plotting the right values here as far as the numeric value. I care about things like, is the graph below the x-axis or above the x-axis? Is it doing this behavior? So you don't have to plug in the exact value. I just want to see, is it behaving like this? Now, once you have this information, you can go about the process of doing all that other work. Notice that let's just go through and answer those questions. A, what is the domain? The domain of the function is going to be negative infinity to negative 5, union with the interval from negative 5 to 0, union with the interval from 0 to infinity. You already know B, C, D, and E. And just real quickly, I'm just going to go through and answer some of these other questions. F, as x is approaching negative 5 from the left, so that minus sign means from the left, f of x is approaching, as we go to negative 5 from the left, the function f of x, y is the same as f of x, is going up to infinity. As, let's go to G, or let's go to K. As x is approaching 1, f of x is approaching what? So 1 is that x value right there. So as you go to 1, either from the left or from the right, your y value is approaching 0. And then L, as f of x is approaching, what is that, 2? F of x is approaching, well, what you have to do here is you have to plug in 2 into the original function. So 2 squared is 4, times 2 is 8, plus 2 is 10, minus 3 is 7. And then 2 plus 5 is 7, times 2 is 14. So 7/14, which is equal to a half. And that's how you would answer some of those other questions. All right. I know I probably flew through this problem, but does it make sense? All right, great. Are there any other questions that y'all want to look at? Grandma? No questions from Grandma. What about our ghoul, our ghost, our ghostly person? I don't know where'd the ghost go? Where's the ghost? That's what William would say. Where's the ghost? All right, no more questions. Y'all good? Okay. At this point, y'all can go ahead and start the quiz. So the facilitator will just pass out the quiz. It's a short quiz. There's only two questions. Make sure you do the question on the front and the question on the back. I gave you plenty of room. Um, and like I said, I will have those videos posted at some point this uh, afternoon for assignment 17. And that's all I have to say. So, um, y'all have a great weekend. I'll stick around in case you have any questions. So, y'all can go ahead and get started with the quiz. I'll stick around for a little bit.
Your conference is scheduled to end in 2 minutes. Your conference is now over. Goodbye.